And we're going to do two chemistry questions today. The first question is, if 25 milliliters of 0.5 molar NaOH neutralizes 35 milliliters of a monoprotic acid, what is the molarity of the acid? So this is a pretty basic question where we're just going to use M1, V1 equals M2, V2. And so we plug in, so the first molarity is 0.5 molar, and the first volume is 25 milliliters. And we're going to find molarity, so we'll leave that. And the next volume is 35 milliliters. And when we plug that into the calculator, we find that the molarity is 0.36 moles of a monoprotic acid. Okay, so for the second problem, we're going to go over here to this fun board, and we're going to balance a chemical equation using linear algebra. So the first step is we're going to change colors here. And we're going to assign, so this is our equation, and we're going to assign x values. So this will be x1, x2, x3, x4, x5, and x6. So what's really important for this kind of problem is you have to construct a vector and keep your variables constant. So construct vector in which we have iron first, so that'll be x1, hydrogen, nitrogen, oxygen, and that's it. So those are our four elements that we're going to be finding. So we're working in R4. Okay. So we know, now we're just going to find our vectors. So for the first vector, we have iron and nothing else. I'm going to add that to x2, where we have hydrogen and nothing else. Here we have 1 nitrogen and 3 oxygens, and 3 up there. And this is going to equal x4, where we have 1 iron and nothing else. x5, where we have 1 nitrogen and 1 oxygen. x6, where we have 2 hydrogen and 1 oxygen. And so we're going to augment this, so we would move all of these over to the other side, so these would all be negative values, and we're going to augment it with a 0 vector. And that will look like something like this. 0, 1, 2, 0, 0, 0, 1, 3. And so these values are going to be negative, so we have negative 1, 0, 0, 0, negative 1, oh, sorry. Negative 1, 0, 0, 2, 0, negative 1, and 0, 0, 0, 0 for the 0 vector. And then when we put that into a calculator, you'll find that you get something that looks like this. 0, 1, 0, 0. And you can use elementary row operations to find the reduced row echelon form, but this is a little easier and more accurate, so we're going to do it this way. 0, 0, 1, 0, negative 2, negative 1 half, 0, 0, 0. So we have some free variables. Here we have x4 and x6 as our free variables. So when we put these back into the equation, or back into the equation format, you know that x1 equals x4, x2 equals 2x6, x3 equals 1/2 x6, and x5 equals 1/2 x6. So then our the x vector looks like this: x1, x2, x3, x4. X4, X5, X6. And when we, with the free variables, you can find the solution, the spanning solution. So we can't have fractions as our coefficients, so we're going to multiply this 1 by 2. And we'll get, 1, 0, 0, 1, 0, 0, 0, 4, 1, 0, 1, 2, 6. And these are our coefficients. So this corresponds to iron 2, our coefficient of 1. Under there corresponds to the hydrogen ion. This to the nitrate ion. And 1 again. Plus 1 NO. And then finally 2 H2O. And you can see that it's nicely balanced. We have 2 irons, we have 4 hydrogens, 1 nitrogen, and 3 oxygen. And that's it. Thank you. I'm Claire Arthurs. Thank you. Have a good day.